I'm your Rupa madam. Today I would like you to discuss about how to write electronic configuration of F block elements. How to write electronic configuration of F block elements is the main first step is the general electronic configuration of F block elements is, as we already know that n-2 F1 to 14, n-1 D0 to 1 and ns2. Here the valence shell has 2 electrons in s orbital. In penultimate shell, that is D, it has 0 or 1 electron. In anti-penultimate shell, F contains 1 to 14 electrons. In F block elements, there are 2 series. What are those 2 series, students? One is lanthanoids and another one is actinoids. One is lanthanoids and another one is actinoids. If you take n is equal to 6 for lanthanoids and n is equal to 7 for actinoids, then it is very easy to write the electronic configuration of F block elements, that is lanthanoids and actinoids. If we substitute 6 in these n values, then we can write it as 6 minus 2 F 1 to 14 and 6 minus 1 D 0 to 1 and 6 is 2. Then we get 4F 14 1 to 14 and 5D 0 to 1 and 6 is 2. This is general electronic configuration for the lanthanides. If we observe the actinides, if we substitute 7 in this n value, then we easily get it as 7 minus 2 F1 to 14, 7 minus 1 D 0 to 1 and 7 as 2. Then we get 5F14 1 to 14, then 6D 0 to 1 and 7 as 2. This is a general electronic configuration for the actinides. This is general electronic configuration for the actinides. If we remember these lanthanides and actinides general electronic configuration, then we can easily write the electronic configuration of the lanthanides and actinides. First of all, see about lanthanides. I am going to write some elements C for lanthanides. See, I am going to write here. Then it is very easy to remember. See here. Lanthanum starts from lanthanum and it ends with lutetium. That means here lanthanum starts from lanthanum. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, okay, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. This is about lanthanides elements. Okay, what is the atomic number for this? Starts with 57, 58, from 57 to 71. Okay, first write these elements and write the atomic numbers of these elements. Then it is very easy to write the electronic configuration of the F block elements, that is lanthanides. Okay, this is about atomic numbers and elements. Then after lanthanum, Z is equal 57 to up to lutetium, Z is equal to 71. These elements are called as lanthanides. Okay, and then see for lanthanum, what is the nearest noble gas is xenon. For lanthanum, what is the nearest noble gas is xenon. Okay, with atomic number 54. Right, first write like this. Okay, then already know that 4F 5D 6S is a general outer electronic configuration of the lanthanides. Okay, I already explained you. Okay, then first of all from 1 to 14. Okay, first of all write these elements, write this electronic configuration xenon 4F 5D 6S for all the elements. If you write like this, then it is very easy to fill the electrons of F orbital, D orbital and S orbital. Okay, xenon 4F 5D 6S, xenon 4F 5D 6S, xenon. If you write like this, then it is very easy to fill the electrons and it is very easy to remember the filling of electronic configuration. Okay, see, similarly here also xenon 4F 5d6s. Xenon 4f 5d6s. Here also xenon 4f 5d6s. Xenon 4f 5d6s. Okay, up to lutetium, fill like this. First of all, write the elements. Next, write the atomic number. Next, general outer electronic configuration. Then, from 1 to 14, how many electrons can accommodate in f orbital, students? From 1 to 14, f orbitals can accommodate 14 electrons. 14 electrons. Then fill like this. Take like this, 1 to 14. 9, 10, 11, 12, 13, 14. Okay, 14 electrons. If you 1 to 14, if you take like this, then if in F half filled is 7 and completely filled is 14, then write like this, 7 and 14. These two are half filled and fully filled. That means these two are stable electronic configuration. These two are more stable, where there is no change in the configuration. The numbers we should not take it in this as 2 and 8. The numbers we should not take it as 2 and 8. Then cross 2 and 8 numbers. Then automatically write, as I explained you in D block elements, how to write electronic configuration in D block elements. In the similar way, I fill like this, 1, 3, 4. If I am crossed 2 means you have to take 3 here, 4 here, 6, 7 here, 9, 10, 11, 13 and here 14. These you have to take the F electrons like this. Okay, don't take 2, so the next number is 3. Next number is 4. Don't take 8, so the next number is 9. After writing this, just fill the electrons like this. Just fill the electrons like this. How we can fill? Here lanthanum is 4f0, 4f0, and next cerium is fill like this, 14 electrons, 4f1. Say next is 3, next 4 like this, 4, 5, 6, 7, 7, and here 9, 10, 11, 12, 13, 14, 14. Here F orbitals are filled from 1 to 14. Here from cerium onwards F block starts. That means lanthanum is not an F block element. It belongs to D. So there is no electrons in F. From cerium onwards these are lanthanoids. So fill from lanthanum cerium of F series. Okay, this one. After filling of F orbital, just see the 6s2 electrons. That means here general electronic configuration is s2, and s2 means s is completely filled. So there is no change in filling of electrons. So fill s orbitals with 2 electrons. Okay, so fill s orbitals with 2 electrons. All the s orbitals with 2 electrons. Okay, 6s2. Now coming to D. How we fill D means, and see here xenon is there, F orbital is there, S is there. How we fill D, students? Here how we fill D means, here for example if you take neodymium, here xenon 4f4 is there, 6s2 is there. Okay, how many D electrons are filled? As we already know that xenon 4f4 5d 6s2. We do not know D orbital. So D orbital we can take it as X. That means xenon is 54 plus F orbital is 4 electrons. D we don't know, X is 2. Here total electronic configuration of neodymium is 60. Okay, here X plus how many? 60 is equal to 60. Then X is equal to 0. That means how many D electrons are filled here? Here in neodymium filled D electrons is 0. Fill like this. If you fill like this, we will get here like this. Okay, 0, 0, 0. Here 1 and here 0, 0, 0, 0, 0, 0, 1. These are the filling of F, D and S orbitals in lanthanoids. Okay, it is very easy. Similarly, if you take anything, then it is easy to fill the electrons of lanthanoids. This is about lanthanoids electronic configuration, how to fill the electronic configuration of lanthanoids. If you like this video, please like and subscribe my channel.